Okay, this is 8.1A. Our objective today is going to be to add and subtract polynomials. So you should have a packet of Chapter 8 notes. If you don't, and for some reason you're at home, then write them on a piece of paper and I'll count that. Fresh start to a new semester. Here we go. 8.1A, first of all, a monomial. The blanks aren't up here, but a monomial is a number or a variable or product of a real number and a variable, or one or more variables, with whole number exponents. So I filled in the blanks there for you by putting the blanks on there. If you're at home, you can just copy that whole term. So an example, a monomial. The word mono means one, singular. Okay? So if we're looking at, anytime we talk about mono, one thing. So this has one term. These are one-term deals. A number, well, 5's a number. So -7 is a number, 8 is a number, 12 is a number. Okay? Those would be monomials. But it can be a variable like x. So it could be t or y. But it can be what we call a product. The word product means you have multiplied either numbers or variables. So we can have 5x because that's multiplying 5 times x. We can have 5 times x times y. Okay? Because that's multiplying 5x and y. Next, what is the degree of a monomial? The degree of the monomial is the sum of the exponents. Now remember, exponents are the numbers up in the air. Okay? And it's the sum of the exponents, but it's specifically got to be the sum of the exponents. Now, it should be added in there on the variables. On the variables. So for instance, this 5, there's no variables. 5 is a constant number. So since there's no variables, if I talked about the degree of that would be 0. There's no variables. If there's no variables, it has no degree. It's got a 0 degree because it could have a 5x to the 0, but anything to the 0 is 1. 5 times 1 is 5. Okay? That means the variables have no power. This one, the x has a 1 power, so that is a 1 degree. This one, the x has a 1 power as well, so that's a degree of 1. This one, the x has a 1 and the y has a 1, so we do their sum, and sum, the word sum means add them, so that one has a power of good. All right? So then down here, we look, and we say, what's the degree? There's no variables, so what's our degree? 1. Oh, now we've got a couple of variables. Remember, the a has a what on it? And then you have those, so that is a, okay? This one is degree. It's got a 5th power, right? So everybody see that over there on the side? Everybody got it? All right. So mono means one term. Next, we have what we call polynomials. Okay? So before we get to that, we have different classifications. Now next year you might sign up for geometry. So in geometry, they'll call things quadrilaterals. What does quad mean? Anybody know? 4. Yeah. Okay. I mean, a quad is a vehicle with four, right? If you've ever seen one of those, okay? Four wheels, okay? But a quadrilateral is a four-sided shape. So if we look at quadrilaterals is the broad definition. It has four sides, but underneath quadrilaterals, there are special types of quadrilaterals. For instance, some are called rectangles. Rectangles have four 90-degree angles. Okay, it's like a shoebox when you look at the top, but it has to be four 90-degree angles specifically. Then there's some called parallelograms. You don't have to write this, but this is good just to get an idea here. Parallelograms, the sides are parallel. So this side and this side here, they don't intersect. They're like train tracks. Okay? Don't cross. Same thing here. This side and this side don't. But they're not 90-degree angles. Now, a rectangle actually is a parallelogram because its sides are parallel. So all rectangles actually are parallelograms, but not all parallelograms are rectangles. All parallelograms are quadrilaterals, but not all quadrilaterals are parallelograms. There's different kinds. We also have one's called trapezoids. The trapezoid only has one pair of parallel sides, and then the other sides look like that. Okay, we also have squares. Now a square has four equal sides, and a square is a parallelogram. A square is a rectangle. But a square also has four equal sides and four right angles. All squares are rectangles. All squares are parallelograms. All squares are quadrilaterals. But not all rectangles are squares. Am I making some sense? Because a rectangle, if it has different lengths, isn't a square. But a square is always a rectangle. Now there's one other type, and it's called a rhombus. A rhombus has four equal sides. These four are equal, but it doesn't necessarily have the four right angles. When you combine the rhombus and the rectangle, you get the square. And actually, a rhombus is a parallelogram. The other thing about a rhombus, if you got on the bus this morning and you ended up at Lincoln High School, you got on the wrong bus. Now, anyway, that was supposed to be funny, but not many people laughed. Let's see, wrong bus. Come on, where's the laughter? Where's the love? All right, anyway, polynomials. A polynomial, the word poly, why did I go through that? Not every shape, some shapes are under the other, but not every shape on the bottom, or not every shape on the top is one on the bottom. So a poly means many. Now many can mean one term, can mean two terms, can mean three terms, can mean four terms, can mean five. So polynomials have many numbers. The word nomial means number, many number. So a polynomial can be a monomial, or it can be a sum of monomials. So for instance, again, 4 is a monomial. It's also a polynomial. 3x is a monomial, and it's also a polynomial. It's part of the bigger family. But this one, 4x and 6, when we sum them, when we add them, now that one has two different terms, and they can't be put together because they're not what we call like terms. We can't put that together and get 10x, right? Because it would have to be 4x plus 6x. If it was 4x plus 6x, we'd get 10x, it would make it a monomial. But this one actually is what we call a binomial. We'll see it on the next page. Binomial, like bicycle, means two terms. But a binomial is a polynomial, many different numbers. This one, what do you suppose it's called? A what? This one, what do you suppose that one's called? It's a polynomial, but what do you think it's called with 3? Trinomial, like tricycle, right? Okay? So, now, a term. We add like terms. So a term is one of the monomials. For instance, that's a term. 4x is a term, 6 is a term. If we had 4x and 6x, like I said, we could combine them, get 10x. We can't. Here, there are 1, 2, 3 terms that can't be added together. You see that? 1, 2, 3. Okay, 3x is a term, 5y is a term, 4 is a term. Now we want to determine the degree of a polynomial. It's the greatest of its monomials. So down here, if I look, this one has 1, 2, 3, 4 terms. Are any of them like terms? Are they like? No. So I can't put any of them together. So this is a 4 term. We just call it polynomial. You could call it a quadnomial, 4 term. Okay. But once we get over 3, trinomial, we just say, hey, you know what? It's a polynomial. It's got a lot of terms. But now I want to know what's its degree. So if you look here, what's the degree of this one? Just that one that I circled. 3. Okay? And you're like, degree, okay, going back, that other page, we look at the exponents. Exponent of 3. So that one has a degree of 3. What's the degree of just that one? 2. Now we are not adding them together. Okay? We're not adding them together. What's the degree of just that one? 1. And the degree of that one? What's the biggest number you see there? So that whole polynomial is a degree of 3. It's the biggest of the terms when you look at the powers. So next, standard form. Standard form is when the terms of the polynomial are written that the exponents decrease from left to right. Your blanks, I'm going to put it better. Greatest degree to smallest degree. In other words, we go from biggest to smallest. That last one, it went 3, 2, 1, 0. That was in standard form because it had the biggest degree first, then the next, then the next, then the next. Make sense? So standard form is how we write it. When you put it in standard form, for instance, this one, going back one page, this one's in standard form. This one is the one with the biggest power. What's the number in front there? Just say it. What is it? 2. That's called the leading coefficient. It is the coefficient of the first term of a polynomial. Sorry, that got messed up there. So the coefficient of the first term, sorry, again, messed up there, of a polynomial written in standard form. Those are your fill in the blanks. I underlined them. So now we have an example, and you are asked to write this one in standard form. So first, can you rearrange that one by its powers? Which power would be the biggest? The 3. Good. So we're going to write negative x to the 3. Make sense? Now, this one's next because it's to the first power, right? So we go plus 15x. Remember, if there's nothing out in front, it's being added. Plus, and then plus 3. What's the degree? Remember, we look at all 3 terms. What's the biggest degree? You did that to start. What was it? 3. Because this is a 3, this is a 1, this is a 0. And we just take the 1, we don't add them up, right? What's the leading coefficient? What number is in front there? Be specific. Negative 1. Okay? Okay. Were you good there? Didn't go too fast? A binomial is a polynomial with 2 terms. So again, we already had said that. I said it would be later. But like this, x plus 3. I can't put those together because they're not like terms. So now it has 2 monomials, or is called a binomial. Like a bicycle has 2 wheels. Trinomial is a polynomial with 3 terms. X to the 4th plus x to the 2nd plus x. That would be x to the 1, the last one. This one is of degree 4. Okay? But I can't put any of those together because they're not the same thing. Now, we have dealt with linear equations. Y equals mx plus b. So a linear equation is typically a first degree polynomial. And again, I'll show you why. Y equals 2x plus 1. Why is it first degree? The power on this is 1. The power on this is 0. So it is a first degree polynomial. Make sense? Now, as we go, we'll probably graph what we call quadratics. Quadratics are what we call parabolas, but they look like this. Y equals x squared plus 2x plus 1. They have an x squared term. What degree is that? 2. Whoop. Second degree. A cubic is a graph that looks like this. If you end up taking algebra 2, but it's y equals, it starts with x to the 3rd. Now it can have more. It can have plus x squared plus whatever, but the important part will be the highest power is 3. You can have a 4th power one, we call it a quartic. It's usually about as far as we go, but you can have 5th power, 6th power, 7th power, it doesn't matter. We can keep going. That's the right part. Where'd my screen go? Find the classification page. That's really dark. Huh. I got the right stuff on here. Well, I guess we're going to make this. Okay, classify. So we have the number 18. It says, what is the degree? What's the degree for that? 0, because there's no x, no y, so there's no power. What's its name? Okay? One term. What do we got? We got a, wait, no. I'm wrong. The name using the degree, sorry. We call that a constant. Okay? Now, 2x plus 3. It's a first degree. We just said a first degree. Y equals mx plus d. What is that? That'd make a line, it'd be linear. So when we're talking about the degree, the next one is 3x squared plus 2x plus 3. Second power, which we just said is called a what? Look back on the page before. Quadratic. Third power. Fourth power. What do we call third? Cubic. And I told you this one. Quartic, like 4 quarts in a gallon. Now, what's the difference between this chart and the next chart? Okay, there is a difference. This one was naming it by degree and the name using its degree. When you look at the degree, we have different names. So the next table says we're going to classify by number of terms. And then its name by number of terms. 18 has one term. It's called a monomial. Okay, because it has one term. That's it. Mono means one. 2x plus 3 has 2 terms. What do we call that? Binomial. (3x squared plus 2x plus 3 has 3 terms called a trinomial. When we get over 3, we get lazy. We just call it a polynomial at that point. Okay. All right. For today, that's going to be the notes.